we heard a variable, so like you can think of a column of numbers as kind of like a variable. It's normally distributed, so it immediately makes me think of the bell-shaped curve, and it makes me think of using a z-score because we can convert z-scores to percentages once we know something's normally distributed. So that's what I got out of this first piece. It's got a mean of 64, so that means it's centered right here. And we're given that a probability that x is greater than 75 is 0.2981, so that's the tricky part probably. But let's draw what that looks like on this normal distribution. Here's 64. 75 needs to be somewhere over here because numbers increase as we read from left to right. And they're saying the probability is 0.2981. That's what the bell-shaped curve tells us is probabilities. So they're saying that this area is 0.2981. So what we can do is we can calculate a z-score that corresponds to this area, and then maybe we can plug it into the formula and see what we got. Because the question is asking for the standard deviation. If we plug in a z-score, if we plug in 75 in for x, because that's the value that we're talking about on the normal distribution, and if we plug in 64 for the mean, then we have one thing left to solve for. It's sigma, the standard deviation. So let's go to Google. I'm going to type in z-score. Sorry, wait, other way around. I want percentile to z-score calculator. Try the first one that comes up. This looks good. This is what we want. We want to type in a percentage as a decimal and then get a z-score out of it. So our percentage, now if you type in 0.2981, the convention in the back of a book or in z-score calculators is always to tell you area to the left. So we want 0.2981 to be to the right. I'm going to take 100% and subtract 0.2981 from it. Probably could do that in my head if I thought about it, but my thinking cap's not on today. Okay, so that's what we want to plug in here. And so that's the z-score that corresponds to that percentile. So 0.5299. So they probably want it to be 0.53. That's probably why the software chose that. So this 75 could be converted to a z-score of 0.53. So let's plug that in the formula. The x value is 75. That's the particular value of that z-score for our distribution. We got 64 for a mean, and we got sigma that we don't know. Now we've got some algebra we can do. The first thing I do with this algebraic equation is I would subtract the top. We got 75 minus 64. That makes 11. And then if I need to get sigma by itself, I can't get it if it's in the denominator. So I'm going to multiply both sides of the equation by sigma, because that makes sigma cancel out on the bottom when I multiply this side by sigma. And now sigma is out of the denominator. Now I can solve by doing the opposite of times 0.53. I can divide 0.53 from both sides. So we get 11 divided by 0.53. Approximately 20.76 is what I got.